Okay, welcome to our trigonometry section of the course. I know that many of you call this course trig. This is where we start. Okay, a little bit of background. As you recall, in geometry, an angle was formed by two rays with a common endpoint. And angles in geometry were limited to those angles which were acute, possibly obtuse, and even what we call a straight angle, 180 degrees. The trigonometry is going to be much different, and the angles aren't limited from 0 to 180 degrees. In fact, angles can have any number of degrees, both positive and negative, and they're drawn in what's called standard position. Now, if we create just a regular old set of axes, an angle in standard position is defined as having one of its sides, one of its rays, right along the positive horizontal axis, which is known as the initial side. Now, the other side can be anywhere, quadrant 1, 2, 3, or 4, and could be measured both in a positive direction or a negative direction. And we define a positive direction as counterclockwise and a negative as clockwise. Positive, negative. So, for example, here is an angle in standard position with a measure of 60 degrees. Well, here's some others. Here's an angle in standard position with a measure of 135 degrees. Here's a measure, an angle in standard position with a measure of negative 70 degrees. But there's more. These angles aren't restricted to 360 degrees. So here's another example. Let's say that this angle has an initial side and then a terminal side, but that it goes all the way around and then some. Well, let's say generally, I should have mentioned this earlier, I suppose, but we label these things as theta. Well, this theta is 390 degrees, which is all the way around another 30 degrees. That leaves this little piece right here to be 30 degrees, and that's got a special name. It's called the reference angle. So we'll get more into that later, but these two angles, 30 degrees, and let me say this one, okay, I'm going to say alpha is equal to 30 degrees. So we go, this small little 30-degree angle and the 390-degree angle terminate at the exact same place. We say that theta and alpha are coterminal angles. Okay. Well, you're familiar with measurement in degrees, in which case all the way around the circle is 360 degrees. Well, there's a more useful measure of angle that you're not familiar with, but you see it on your calculator at times. It's called radian measure. You may have seen that when you go to the mode button on your calculator. You see these two versions of angle measurements, one of them being radians. And you may have never heard of radians. But it's, in terms of scientific and true mathematical sense, it is the natural measure of the angle because it's based on the circle. Now, generally speaking, when we start talking about radian measure, we talk about what's called the unit circle. In which case, I'll draw a nice circle here. Not bad. Label this point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. All right, that circle has a radius of 1 no matter where I go on it, the radius is always 1. Now, if I take the circumference of this circle, and everybody knows that the circumference of the circle is 2 pi times the radius. Now, seeing how the radius is 1, this circumference for a unit circle is 2 pi times 1, or 2 pi. Well, it turns out, and there are more technical reasons for this, but we're going to oversimplify a little bit, that 2 pi is the number of radians all the way around the circle. So we can measure an angle in radians by counting this amount of measurement around the circle as 2 pi. So there's a conversion here. 2 pi radians